Yeah, Mr. Premo, thank you so much for coming and let's have a good one.
All right, thank you very much. Glad to be here. What are we going to talk about today? We'll set the stage with who I am and hopefully why you should pay attention. We'll talk about some opportunities. We have tremendous capabilities and tremendous services here at Mississippi State. I'm willing to bet most of you don't know about this as students. I will offer you some mentorship along the way. My background, notice he didn't say Dr. Premo. I am not an academic. I hate academics. My undergrad is nuclear engineering. My background is primary department defense. I graduated college at the University of Arizona, then mentioned nuclear engineering undergrad. I was commissioned in the Marine Corps. I served 20 years in the Marine Corps. I spent most of my time flying F-18s. A lot of interesting jobs along the way. At the time, I really didn't like this, but as an aviator in the Department of the Navy, we always had an additional duty in addition to flying. So I had ground jobs in logistics, aviation operations, aviation maintenance, and intelligence. If you saw me on Top Gun, the Marine Corps had their own helping school. So I was an F-18 weapons school instructor for SEAler. When I was there, I was heavily involved in developmental and operational flight tests. I also did foreign military acquisition and foreign military exploitation. I'm really focused on fixed wing aircraft as well as threat electronic warfare systems, doing radars, countering the electronic attack and protection activities. I did a tour of the Pentagon. I was the F-18 and tactical reconnaissance and findings officer. I also was on the direct staff of the University General of the Marine Corps. I spent some time as a senior military advisor to the U.S. ambassador in Ethiopia. During a very interesting time in Africa, Middle East. And then my kind of culminated my Marine Corps career. I was commanding of an F-18 squadron, the largest squadron in the Marine Corps. Fear of influence and what I got to do along the way in those 20 years. I had responsibility for myself in some jobs and no one else. And then I culminated my career. I had a staff of 650. Dollar authority underneath me was anywhere from tens of thousands of dollars to about a $2 billion activity. I mentioned my squadron. We had 44 F-18s and a staff of 650. Along the way, I retired from there and I went to the Missile Defense Agency just up the road in Huntsville, Alabama. A lot of acquisition, program management, and engineering positions, but I spent most of my time leading two organizations. One was Concept Exploration, which really focused on transitioning from the 6.1, 6.2 basic engineering and science and technology activities into a deliverable capability. And then I ran the advanced programs for my last 4 years. If you're familiar with Skunk Works, we were kind of like a Skunk Works organization. Very small, very focused, very dispersed around the United States. But it was a great career. You could tell I'm not from Mississippi. I'm not a Mississippi State grad, and I didn't marry a Mississippi girl. The reason I'm here today is I'm a parent. Both of our sons are tied to Mississippi State. My oldest did his bachelor's in aerospace. He graduated in 23. He stayed here doing Thrive and Fly and did his master's and graduated this last May. He's a developmental flight test engineer in the Air Force. Our youngest son is a senior this year in business information systems. He's going to go on cybersecurity, cyber operations in the Air Force. And then our youngest nephew is in the College of Business PGA management program. So I am here, started this journey 7, 8 years ago with my oldest son on the college tour. And I realized back then that the university takes care of what matters. So I'm glad to see that they've adopted the motto. And it was really as a parent, I could not have been more impressed with the university, the faculty, and the staff. They took care of the students and they took care of me as a parent. So when I got the chance to retire from Missile Defense Agency, I applied for jobs here and I told my boss, who's the associate VP for research, I said, I'll cut the grass, I'll take out the trash, I'll do whatever you want. I just want to come help the university in their mission. So I highlight that. We're going to talk about some things in terms of mentorship. First of all, freshmen, okay, sophomores, juniors, seniors, just a few grad students and some faculty and staff. We're going to talk about mentorships. Yeah, Rosemary? We can always talk.
Yes.
Yes?
Built, yes.
Built.
but-
Okay, yeah, okay. Rosemary? High school? Most students do not have resumes. And most students, when they come to see me there, I wouldn't really say that they're very good at resumes. With that said, that is the service that I offer to you as a mentor. When I was at this defense agency, 13 years, I was a hiring manager all 13 years. I put on and I staffed hiring fairs in the Huntsville, Alabama area. I have reviewed hundreds and hundreds and hundreds of resumes, if not thousands. And I have interviewed many people. So I offer that as a mentor service. If you want to have me look at your resume, please let me know. Or we could talk about internships, co-ops, et cetera, et cetera. There's this magic force field that exists along Highway 182 because no academic will cross that freeway and no student will either, right? It's even worse out at Raspet and the Advanced Robotics Institute because we are so far away, 4.5 miles door to door. No one ever goes out there, right? When I'm done with this and you hear about the capabilities, I think particularly the freshmen and sophomores, you're gonna be like, why didn't they tell me this in introductory tours? We are an R1 research university. We're top 100 in the United States. That R1 is extremely important. It's basically tied to the dollar value of the research that we bring in, as well as the number of PhD students that we graduate. This is known as our research park area. I'm going to talk through a couple of the centers. Many of you are familiar with CAV, the Center for Advanced Nuclear Systems, that's located right here. Directly behind that is a 55-acre off-road proving ground. Directly at the 9 o'clock-ish position here, this is the High Performance Computing Center. Directly over here in this grass spot is our new data center that will come online next summer. There are a number of corporate partners in there that exist, and there's a lot of open industry space that we're bringing in, everything from small startup tech companies to major contractors. I mentioned the High Performance Computing Center. Depending on the day of the week of the month, and the month of the year, we're between the 4th and 6th fastest supercomputer in academia in the United States. We have 2 on the top 500 in the world. The new data center, this architectural rendition, the bottom right here, it's pretty doggone close to reality. That opens and is fully operational. We have initial operational capability next summer is going to increase our capacity by 2.5 times. The first system that's going to go into that facility is rumored to be top 20 or top 25 in the world. Right here in Starkville, Mississippi. Now, one of my pet peeves, again, I mentioned my oldest son, Ryan is his name. When he was a senior, I joined the university middle of January. He's now in his 2nd semester of the senior year, getting ready to graduate. A couple of things. He had never been to Raspet, nor had his entire graduating class of aerospace engineers. Additionally, he was doing a senior design project, and he got the task of doing all the modeling and simulation because he had the fastest personal gaming computer of his peers. And he would run that stinking computer 24/7, doing all this modeling, heating up our house nonstop. And I said, we've got this for the 6th fastest supercomputer. Why is that just for faculty and staff doing research? Well, that's the way it was set up. So we did some things and we worked together and we've now procured a GPU-based system. It's known as Ptolemy. If your faculty member reaches out to Mike Novicki, who's the director of the High Performance Computing Center, and says that his or her particular class has a need for this, we will come over and we'll teach the class how to access Ptolemy remotely. That gives you access to supercomputing as an undergraduate student. Freshman, sophomore, nowhere else in the United States does that exist as an undergraduate. Nowhere else. You will eventually do something requiring intensive modeling and simulation. It's just an undergraduate or go for your master's degree. Okay, that is a huge capability for you guys right here. This is a list of some of our roughly 16 principal centers and institutes that focus on that high performance computing. We're going to talk about a few of these. Any questions on the HPC? Okay. Interesting, we got this thing started about 30 years ago. Our first major contract was with NOAA, the National Oceanographic and Atmospheric Administration. Everyone watch the Weather Channel? All those models that you see on the Weather Channel, where are they? Where's the modeling simulation done? Orion supercomputer sitting in Starkville, Mississippi. Along the way, several years ago, and we do this yearly at Raspet, we'll take our large group UAS with multispectral cameras, and we'll fly sorties and gather imagery along the river. With that multispectral imaging, we're able to see things that you can't see necessarily with the naked eye. We take all that data and we push it back to the supercomputers and they update their models. In the last 7 or 8 years, NOAA has gone from 1 foot accuracy on the river in the floodplain, now down to 7-meter accuracy. And the predictive modeling is able to tell when we have a catastrophic event coming, tell you need to leave in the next 5 days because your property is going to flood with this probability, but your neighbor's good to go. So a lot of very interesting capabilities that exist out there. ASSURE, the Alliance for System Safety and UAS Research Excellence, known as ASSURE. The Federal Aviation Administration is very interested on how we fly, operate, and integrate large group unmanned uncrewed drones in the national airspace. A lot of words. Not to insult your intelligence, UAS are categorized numerically from 1 to 5. Group 1 is something under 55 pounds. It typically flies less than 400 feet. You see a lot of amateur operators flying these. You'll see the drones at sporting events. A realtor use it to take pictures or video of your house. Group 5 is what we typically see advertised on, or you see it on TV from major defense contractors that are flying significant ranges, significant altitudes. So the FAA established this Center of Excellence through a competitive action about 2016. And Mississippi State submitted a winning proposal, and that Center of Excellence is known as ASSURE. We are a consortium of 30 U.S. and international university partners. We have a master teaming agreement in place. So the FAA comes down and says, I am interested in human factors or human machine interface or cybersecurity or low altitude operations. And that goes to ASSURE, and then ASSURE will send that out to all those university partners. Based on our expertise, we will then turn around and do that work for ASSURE. I know a number of faculty have helped on a number of these projects. I think we're up to 85 projects since 2016. Great opportunity, and we'll talk about RASPET since they're one of the key leaders in the organization as well. I mentioned large group drone aircraft. RASPET has the largest group drone fleet in academia in the continental United States. The only other one that flies large group drones is University of Alaska Airways. In the state of Mississippi and our adjacent states, we now have 85,000 plus square miles of improved airspace to fly large group drones in the national airspace. Those two things do not exist anywhere else in the continental United States. We have just put together an all-weather facility. So if you think of a wind tunnel, but it's tailored specifically for UAS research, development, test, and evaluation. That's a multi-phased approach. We're going to bring in moisture and we're going to bring in humidity and all those sorts of things. But think about everyone wants their toothpaste delivered by Walmart today, right? How are we going to integrate all those UAS operations into a very urban environment? Think about the temperatures and the pressures and the wind that exist in downtown Los Angeles, New York City, et cetera. We need to be able to test to that. I mentioned the Center of Excellence. We're also the Safety Research Facility, and we're the Department of Homeland Security's Common UAS Test Center. All of these research centers focus on applied research. Your experience to basic or fundamental research in the academic classroom. I tell people it's basically you're going to a whiteboard or a computer, and you're going to try and derive something. Is this potentially feasible? Can we do something in a number of years? For our applied research, we're delivering a capability in 12 to 24 months. So we solve people's problems very rapidly. At RASPET last year, the Department of Homeland Security's component, the Homeland Security Investigations folks, came to us and said, hey, we need a Group 1 drone for our folks that are basically going to be going into high-risk areas that are going to be serving and executing warrants, right? They're going into a building, rooms within buildings, and they're looking for bad people. We need a drone because industry has not met that requirement. So the engineers at RASPET designed, built, tested, and then delivered 3 of those drones to HSI. Okay. This coming year, we're going to do a micro drone. So the Customs and Border Patrol component said, I want a drone that I can launch by throwing it out of my hand, and it has to be idiot-proof. And it has to be indestructible. Right? We want any idiot to be able to fly this thing. If they hit a wall, it doesn't break, right? So we're going to talk about how we're going to solve that problem in the next slide or two. At RASPET, staff of about 60, half of those are undergraduate and graduate students. Are any of you student workers? You wrote Sanderson. What do you do? $10.
No, supervised competitive sports.
Oh.
I actually have worked tonight at 5:30.
Okay, well, that's a pretty good one. Most student workers, when I was a student worker, we answered phones. Most of our student workers will run administrative errands for us, right? As a student worker at any one of these research centers, you were going to do the technical work of your academic degree. Okay, and it's not just engineers that we want to hire. I want business people, right? Because all of these contracts at RASPET, we have 20 contracts on any given day that we're executing, 20 projects. I need people that can oversee those projects and execute, be responsible for the cost, schedule, and performance of the contract. I also need people that understand how to go out and look for proposal and grant opportunities, those sort of things. So I want business students as well. The great thing about these research centers is you can come in during the school year and you're basically getting that internship opportunity while you're sitting in the classroom and start. You can work up to 20 hours a week. You can come in, you can go to RASPET for a semester. You can turn around and go to CADS for a semester. Go to athlete engineering. You get all that expertise that your peers are not getting. It's going to make you more competitive when you graduate from college. Any questions on this one? There's some pictures of RASPET. I mentioned earlier, student organizations. You guys should be going out and picking some of these centers and doing tours on your own. RASPET, I think last year we did 2,500 individual people for tours. My first year, I did over 100 corporate engagements here in Starkville. So we have some great opportunities. I mentioned group size. This is a group 4. I tell people when you go see RASPET, you are going to see the Smithsonian of the South. The aircraft that exist over there are truly one of a kind in their pristine condition. That is a group 4. That is a 40-foot wingtip structure. It is about 2,000 pounds gross takeoff weight, and it has the capability of carrying 400 to 800 pounds of external payload. Think about the interesting things that we could do. I mentioned this earlier offline. This cowling that sits over the aircraft, when you're looking to have the ACI remanufacture a new cowling, and we're going to slap a Starlink antenna on it. So now, as we've seen most recently, hurricane comes through, tornado comes through, it wiped out the cell tower network, and no one can talk. This aircraft has the capability of flying 24 hours time on station, up to 20,000 foot ceiling. I have 2 of those. Based on physics and line of sight, they operate 60 to 100 nautical miles away from the ground station. So think about it, I could have ground operations, air operations extending throughout the state of Mississippi if we had that natural disaster that occurs. Yes, up to 24 hours on station. Okay. Good question. There are 2 of those at RASPET. There are 4 of those in existence today. This is a Tiger Shark, which is a group 3. This is about 600 pounds, and it has a 95-pound payload. There are 4 of those. It's nice because these have ICD compliant hard points and interfaces that allow us to do a lot of different things for military and federal customers. Not depicted on the slide, I don't think. Well, here's a couple. We have 3 manned aircraft. Right now, today, in the national airspace, if you want to fly, you have to have a pilot that maintains visual separation from the cameras. How do I do that with the drone that's flying 60 or 100 miles from the operator? Well, right now, we generally have to do that with chase aircraft. So we have 3 aircraft over there, 1940s vintage World War II Boeing Stearman trainer, just pristine condition. We have a Grumman Tiger, which is number 1 off the production line. Then we have a 1960s vintage Cessna 172 that was designed and built for the Marine Corps for Vietnam. Amazing, amazing aircraft. The Air Ops team over there does everything from the maintenance, building aircraft, building small micro cubs, etc. A lot of really interesting things. Again, I encourage you guys to go over and take a tour. Just celebrated its 75th year, the longest serving research center in Mississippi State. All loyalties aside, this is probably one of my most favorite institutes based on the technologies that they're doing. They do 3D stitched resin infused composite manufacturing. A lot of words. Traditional aviation services, we do carbon fiber, we layer that together. We may put some material in there, they diffuse together on temperature, pressure. Typically put it in an autoclave and do those sorts of things. It has one big negative in my mind. It's very susceptible to water intrusion. I mentioned that I flew F-18s. Before I retired, I was on a deployment down to Key West, and we were doing an air-to-air gunnery shoot. And I came off the target, the last run, and my wingman said, "Hey, are you okay?" Yeah, why not? He goes, "Check your rudder and your stab." Looked at the computer, flight controls, nothing. I turned around to look, and 3/4 of the stab was gone because it had delanded. Those loads in flight and water intrusion. I was that thing to rip off. Okay. Great testament to the aircraft. I didn't have to do anything crazy. I did some slow speed characteristics, flew in and took a trap, no issues. But what this technology does, again, it takes now the material, puts that resin together, material, resin, puts it underneath a vacuum, and then they put in a stitch in the Z-axis at specific points to minimize that fatigue and those load factors. What's that do? 1,000% increase in toughness, about a 60% reduction in weight, about 1/5 the cost of current manufacturing. Amazing capability. It's not just applicable to military aircraft. It's applicable to automotive industry, military vehicles, structures. If I want to build a Faraday cage, I could use the same technology. Hypersonic components, wind turbine blades, helicopter turbine blades, et cetera, et cetera. About 2 years ago, the Department of Defense said, "Hey, I need the next generation of long-range manned aircraft." I think something like a tanker. I need it to do this, this, and this. Had all these strenuous requirements. Those requirements could not be met by current manufacturing. So that company that won the contract was known as Jet Zero. Jet Zero has since partnered with Northrop Grumman, and the ACI is producing the prototype components for that next generation aircraft friendly body. They're also producing prototype components for hypersonic vehicles and space vehicles. Some of the really interesting things, they're AS9100 certified and ISO 9000 certified, which basically means they're doing this and they're not using duct tape and toothpicks to put it together. They have some established processes, a lot of one-of-a-kind capabilities. I mentioned the 3D stitch resin. This has a capability of generating 100-foot tip-to-tip aeronautical structure. So think a wing, an elevator, etc., or an air vehicle that's 100 feet long. 2 of those are in existence in the United States. NASA Langley and Starkville, Mississippi. This one, the new RTM just got there in the last 2 months or so, that now allows us to produce aviation quality components at an automotive rate. So automotive components, we're taking a component, an aviation component that today would take 1 hour to produce. They're producing it in 5 minutes. 1,000% increase in toughness, 60% reduction in weight, and 1/5 the cost. That is revolutionary and evolutionary on where things are going. Okay. Really amazing. This is another one, the thermoset printer. I'm not a composites guy, so don't start asking me composite questions. Dr. Bounds and Dr. Huber, you're polymer chemists, you know much more than I do. But I was on a corporate tour a couple months ago, and one of the research engineers was generating a tool. And the nice thing, many nice things, the chemistry involved allows them to turn it on. An hour, 2 hours, 3 hours, whatever it is, they could turn it off, they could leave, they can come back and turn it back on, and that they're not losing anything. It also allows them to plug and play components together so they can make tooling structures significant distance. I talked to them, and I think they'd done like a 12-foot tool just by plugging these together. But I asked Dr. Bounds, I said, how much for the material and the labor to produce that part that they're doing right there? He said, that's going to be about $4,000 or thereabouts, $4,000 to $6,000. I said, how much is traditional industry doing that today? Because 6 figures, low to mid. So we get a lot of work and a lot of interest from industry on, can you generate these tools and that sort of stuff. Questions on that one? Many of you are familiar with CAVS, the Center for Advanced Vehicular Systems. I tell folks what Elon Musk is doing with on-road autonomy, we're doing at Starkville, Mississippi with off-road autonomy. A lot of really interesting capabilities. I mentioned the 55-acre proving ground out behind CAVS. They are heavily involved in materials and metallurgical science, as well as additive manufacturing. Of course, we'll talk about athlete engineering in a second, and vehicles. They're part of a consortium known as Magnet, which is the Mississippi, Alabama, Georgia network for electric vehicles and things, or something like that. They're trying to solve the problems in the southeast region with the next generation of vehicles. All things related, not just electric vehicles and hybrid technology. They are very involved in computational fluid dynamics, so they're a principal user of the High Performance Computing Center. They did some work with industry a number of years ago. Military vehicles built up here in West Orange, and the task was to, can we reduce the weight of these vehicles by X% without degrading any of the physical capabilities or the survivability of the vehicles? So they were able to do some things with different alloys. And then they also brought in the ACI team to generate some components for them. Another thing about the ACI, they do a lot of outreach for K-12 and up. So we're trying to get the next generation of STEM workforce. You as a student worker can go out there. They have a 1940s or 50s Jeep that the students are remanufacturing and utilizing the technology. They have the old hood that probably takes two of us to lift and manipulate. And then they have the new hood that I can lift with one arm. So some great technology. The students out there, they build guitars, they build skateboards, they build cornhole, they build all sorts of things. Whatever you want to do, you can do with the technology. It's really interesting. We spoke earlier a little bit about the agricultural activities. You guys see this last year that were here, students? Press release. Things that are dull, dirty, or dangerous are really prime for autonomous, unmanned, or uncrewed systems, whether they're ground vehicles or airborne vehicles. Herding dairy cattle, you got to do it every 12 hours. Right? One's pretty easy to do when you get the really early morning. That may not be so good, but we did. This was a research activity where we had an autonomous ground vehicle and we had a drone taking some imagery. And we utilized these to get the dairy cattle to go in the right direction. Right. Some other things that they've done. Again, you've seen this on TV and whatnot. They've designed systems that will go up and down a road, and it's using multispectral cameras and artificial intelligence and machine learning to look and see what is that fruit ready to pick. Is there something bad on that piece of fruit? Do we need to have more fertilizer, more pesticide, or more water? All those things. They've designed devices that can go up and down, and now they're going to map and they're going to zap weeds, that sort of stuff. That's one of our newer centers. A lot of interesting things that are coming online. One of my areas of interest is tied into the military is autonomous logistics. Think about that. Same thing for them. They're interested in how they could do that stuff autonomously. Athlete engineering. This is another really cool one. Dr. Ruben Birch, many of you would know Ruben very well. The IISE departments. He used to work for FedEx in their innovation activities. He has broken down athletes into 4 categories, and they're just now coming online, I believe, with the 5th category. Humans, everyone's familiar with the traditional sport athlete. This is where Ruben got his start. He was a former Mississippi State football player. He is focusing on enhancing human performance of the athlete through wearable technologies. So it's not just a GPS watch or Garmin or Fitbit or a ring that you wear. He's focusing on things that people will actually wear in a piece of clothing that you will like to wear. So his student workers are multidisciplinary areas. He has students that are studying textiles. He has students that are studying fashion merchandising. He has cybersecurity and electrical engineering and computer science because they're designing and writing the code to go in these devices. Some interesting things that they've done along the way. One of the big challenges as an athlete is heat exhaustion. Okay. How can we monitor your body temperature the most accurate way? So they're looking at right now, think about earplugs going in your ears, one of the best ways to get your core body temperature. And now that temperature is continuously available to someone in your local area network. So think about first responders or sports athletes or tactical athletes in the military. As your core body temperature starts to rise, it's very quick on that slope from bad to really bad in your gut. I know your core body temperature. We could do some things preventatively before we get to that catastrophic failure. One of the things that they've done is they developed what's known as a CoolKnit. This is through a DARPA project. Anyone heard of CoolKnit? Football players, many times you'll see them, and it's literally a device that you put your hand in. You have the most capillaries in your hands and in your feet. So periodically throughout a football game, you'll see professional athletes go over, put their hands in. We found within about 2 to 3 minutes, you're lowering your core body temperature by about 3 degrees. Great capability. The next generation they're looking at is a device like this size. You can now carry around, we can put in the backpack. Again, if we could do this throughout your physical evolution, we've proven that you're able to go farther, faster, longer, better human performance. Anyone go to the Athletes Engineering Summit last spring? It's in April, I think, this year. Students should go for free. Ruben has the best swag in Mississippi State. Okay? You're going to hear some really cool, impressive speakers and presenters. We had a NASCAR driver. We have strength and conditioning coaches from colleges in major sports. We have college coaches, professional coaches. You have all these people come and talk about enhancing human performance in their area. I mentioned NASCAR. 500 miles, going left-hand turns, really, really hot in Talladega, Alabama, right? Think about a coolant device that can go in a shoe. But I have that constantly available to lower your body temperature. The industrial athlete. Pascagoula, Mississippi, Ingalls shipping your welding in the bowels of a ship in August. It takes you a half hour, 45 minutes to get to the bottom of the ship up top side where a cooling station may be available. They have a lot of heat cabins. Ruben was able to take and utilize this technology, design a lightweight, relocatable structure, and now we're able to decrease those heat casualties pretty significantly. A lot of interesting things. Interesting time. I'll leave those to later. This is my area, cybersecurity. Anyone interested in code? I took one class many, many years ago. I swore I would never take any more. But electronic warfare or cybersecurity is extremely important. Think about the wearable device. How do we make sure it's a cybersecurity device? You see it all the time, ransomware activities, etc. Now, we have a program. Anyone heard, undergrads, you heard of Viceroy? Very good. Everybody write this down. Viceroy is a program, it's an incentive program for you. Got to be a U.S. citizen. We want to incentivize you to take courses that will maybe make you potentially have an interest in future employment with the Department of Defense. You're not signing a contract, you're not enlisting, you're not going on active duty. All you are signing up for is, I may have a potential interest in future work. What you're going to do once you're accepted is you're going to take academics in two areas. Languages of an adversary, and then I'm going to say some STEM academics. It could be a cybersecurity class, it could be an advanced programming class. There's a whole list of things that you have. Okay? You take 3 classes in those 2 areas. Every time you take a class, we're going to give you money. Typically, around that junior, senior year, we're going to give you the opportunity to take it's not on this list, we have a class, a Security Plus bootcamp. Security Plus is one of those rudimentary or fundamental certifications that many engineers get early in their career. It's extremely sought after. My staff has developed the courses when we give you a 40-hour bootcamp that prepares you to take that test. Last year, I think we had 14 or 15 of 19 students take and pass the test. We're going to give you some more money to pass that test. You do those 3 things, you're getting $5,000. If you're a freshman and you build your schedule based on this, every class that I said you have to take, you're going to take your degree into account with it. Both of our sons are Viceroy students. Both of them got a lot of free money for different classes. The other thing that we have is we have 2 internship opportunities. The first one's between your freshman and sophomore year. Second one is sophomore and freshman and sophomore, and then sophomore and junior. First one, they're all fully funded. About $25 an hour, 40 hours a week. First one, we're going to send you off and you're going to go to Rome, New York, and you're going to get a chance to learn about cybersecurity in the Department of Defense. Second summer, if you're selected, you're actually going to go do cyber-related work. Could be something writing policy. It could be talking about weapon system deployments. If you like doing coding, you could be doing offensive or defensive activities. Wide list of opportunities. Both of those internships are highly sought after, very competitive, but they're great opportunities. 410 universities fully accredited by the National Security Agency for cyber academics. We have the 4th largest cyber core program in the nation. And we also do a lot of things from reverse engineering, wireless security, supervisory controls. Here's a picture of somewhere it was some lab equipment. So if we want to go ahead and learn how to shut down things, or if we want to learn how to protect things, it could be the infrastructure in a bank. It could be a water pumping station. It could be a centrifuge at a nuclear reactor. It could be just about anything. We have the capability to duplicate that and allow the students to play those roles. I did have an ISA student last year that worked for me as an undergrad, working on some of our laboratory equipment. I am executing a grant this coming year where we're buying all new SCADA equipment, and we're buying all new digital forensics equipment. So I will probably have opportunities for undergraduate students there as well. Questions? Comments?
I do have a question, more for our grad students. Are there any opportunities for grad students?
Great question. So I'll answer that in just a second. I'll tie it all in. All the undergrads are familiar with Thrive and Five? If somebody tell me about what it is. What are the requirements for Thrive and Five? So there's a GPA requirement. I don't know what industrial is. I know my son did aero. His was a 3.5 to 60 hours. Most engineering disciplines are pretty doggone close to that. What's it giving? Yep. So you're going to go and you can take typically up to 9 hours of technical electives required as an undergraduate student. Typically your junior and senior year. You apply to the program, you get accepted, and then when you go to take the class, you have a list of classes, 400 level or 4,000 level class, and it's also a 6,000 level class. You're going to go and sign up for the 4,000 level, then you're going to go to your advisor, they flip the switch and let you go back in and check the 6,000. So you two are taking the same class, you're in Thrive and Five and you're not. You're sitting side by side taking the same class. You're getting graduate school credit, you're not. Typically, this could be intimidating. Again, my oldest son did. You may get an extra problem on a homework. You may get an extra problem on a test. He had to write a couple-page paper. It's not that much more work. You may say, Rob, I have no desire to go to grad school. Forget it. There's no way I'm getting out of start. That means you change your mind your senior year. Now you're paying for 9 extra hours of graduate school, and that takes extra time. Oh, by the way, that Thrive and Five is not costing you any more money. It's already covered in your undergraduate school. Okay. If you do things smartly in your last semester, and I think it varies by this. I had a cybersecurity student who I think it's 13 or 14 hours your last semester. You could then take a grad school class in probationary status. He did that. So he was able to graduate as an undergraduate with 12 hours done, starting his master's 2 weeks later in May. Great program. Now, there are a million ways to go to grad school. We have so many opportunities. They're going to pay you and give you a stipend. Okay. Graduate teaching assistant, graduate research assistant, graduate services assistant. Those are all opportunities. Graduate research assistant, just like not undergraduate research assistant. You go to faculty that are doing some principal research, see if there's an opportunity for you as a graduate student or undergraduate student. If you're a graduate student, you work on your thesis. Again, you could be a teaching assistant. Okay. They're going to give you free tuition and fees, and they're going to pay you some stipend. My oldest son, he did that in senior year, fall semester. He got an email from a professor that he had never had it. Right. I would like to offer you a fully funded graduate research assistant position, yada, 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 all paid and a stipend. And he's like, Dad, I have no idea who this guy is. What's on? How did you know about me? That sort of stuff. Well, you're doing Thrive and Five. Your reputation exists between the aerospace and green. A lot of great opportunity. Another opportunity. You graduate and you say, hey, I want to go to grad school, but I don't want to be ERA or GTA. And what else can I do? You could be a graduate or you could be a research engineer at Mississippi State at one of these centers. You're now a full-time employee. I'm paying you and giving you all the benefits. And oh, by the way, Mississippi State University is going to pay for up to 18 hours per calendar year for you to go get a master's or a PhD. Great opportunity. You want to tie to one of the research centers? I mentioned all those contracts that we have. Every contract we put undergraduate students and graduate students against. We are submitting proposals many months, 6 to 9 months in advance. I may not know who that person's gonna be. I may not know the discipline that I'm having available to me. So you could be a graduate student and get it tied to that center, much like a graduate research assistant. You're gonna work about 20 hours a week. I'm gonna give you a stipend. I'll pay for your school. Great opportunities. Can I answer your question?
Okay. What else?
Okay. I'd like to push you to our websites, like many of us, we're busy, our websites are dated and that sort of stuff. But all the websites at msstate.research.edu, you could go and put the center's icon. You'll at least get to our people, and you're gonna see the director, and then the people below the director. You could reach out to the director via email. I'm John Doe, I'm an undergraduate studying IISE. I'm very interested in student work opportunities. Can I come talk to you? I talk to undergrads and grad students on a weekly basis, whether it's about opportunities like this, or reviewing a resume, or talking to you about how to interview. Or for the juniors, seniors, how do you interview and how do you negotiate the job offer? Things to think about. I would be remiss in my duties if I didn't try and convince every one of you to stay, Sarko, Mississippi, stay here in Mississippi and work. We are the #2 state in the nation for the biggest brain drain. You guys get your degrees, you all go off somewhere else. Every engineer loves to go to Huntsville, Alabama, right? It's close. You're from the southeast, you're close to mom and dad, that sort of stuff. There are a million jobs in Huntsville, and they pay very well. But I lived there for 13 years. The cost of living has gone through the roof. Competition has gone through the roof. Okay? You can get the same opportunities, the same experiences working as a Mississippi State University researcher. Do it for a couple of years after you graduate, knock out your master's that way. Maybe you decide to stay here and be an adjunct faculty member, associate professor. You could do that, or you say, hey, this has been great. I want to now experience another industry. I'll go to Huntsville, I'll go wherever else. Last story. I was here 6 months. I spoke with one of the newly graduated aerospace engineers from a master's program. I knew she had accepted a job in San Diego, California, major defense contractor. I knew what her benefits package and salary looked like. I asked her, I said, did you do a cost of living analysis? She said, what's that? I said, I did. I know exactly how much you're gonna make, and I know the benefits package. And guess what? If you would have stayed here and applied, I put my hand on her boss's shoulder. I said, what he would have offered you is exactly in line with what that major defense contractor is giving you in San Diego. That's before the request came to me. I would have given you more money. And we would have paid you a PhD. Go to San Diego. You'll love it. I lived there twice. But remember, you can come back and start working. That's it. Okay, I'm gonna hang around. You guys obviously want to eat some free pizza. That is my MS State email address. As I mentioned, there are 4 of us that are on there. We're all related. If you send an email to my nephew saying, Mr. Rob, I want to talk to you about a resume, he's gonna know to send it to me. Okay, that's my personal cell. You can text me if you got questions. Okay. Thank you.